Assalamualaikum and good day. So today we will continue with the subtopic 3.2.4, which is derivative of t transform. Okay, so derivative of t transform is one of the method to find the Laplace transformation of a function. If before this we have learned about the first shift property and also the second shift theorem, where for the first shift theorem, it is a Laplace transformation method for a combination of two functions where one of the function is exponential function. Okay, where for first shift theorem we have used the first shift theorem when we want to find the Laplace transformation of two functions where one of them is the exponential function. Okay, so here we will use the first shift theorem, where the formula of first shift theorem is fs minus a, where fs is the Laplace transformation of the function ft. Okay, then we have second shift theorem, where second shift theorem is the method to find the Laplace transformation of two functions where one of them is the unit step function ut minus a. Okay, therefore if there are a combination of a unit step function with any function f, we can find its Laplace transformation by using the formula exponent negative as times with fs, where fs is the Laplace transformation of function ft here. Okay, so now we want to see how to find the Laplace transformation when it involves the combination or the product of two functions where one of the product is the t to the power of n. Okay, you have a function t to the power of n as one of the function here, and it's timed with any function ft. Okay, so we have a few steps in finding the Laplace transformation of the combination of these two functions. So the first step is you need to find what is the value of n, where the value of n can be obtained from the t function t here. So you can find the value of n and write down what is the value of n for step number 1. For step number 2, you need to find what is the fs, where fs is the Laplace transformation of the function ft. Okay, so you will take the function ft from the equation here and find its Laplace transformation. Then for the step number 3, you will find the derivative of fs and times. Okay, for example, if you have n equal to 2, therefore we will differentiate fs 2 times. If we have n is equal to 3, therefore we will differentiate f 3 times. Okay, so value of n is very important to be correct. Okay, and the last step for this method is you need to times the answer that you have in step number 3 with negative 1 to the power of n. Okay, so in step number 3 you have the derivative of fs n time. Okay, so this derivative of fs n time will be times with the negative 1 to the power of n. So this is the step in derivative of t transform. A few examples here. You need to find the Laplace transformation of the first the function t sine 3t, and second the function t square exponent 7t. Okay, so let's do the first one first. We want to find the Laplace transform for function t sine 3t. So if you see from this equation, you have two functions. Okay, the first function is t and the second function is sine 3t. Okay, so when you have a combination of a function with t, therefore we will use the derivative of t transform. Okay, so we have a 4 step to do the derivative of t transform. The first step is the value of n. So from here you can see that the value of n is equal to 1. Okay, the value of n is equal to 1, therefore we write n is equal to 1. For step number 2, we need to find what is the Laplace transformation or fs. Okay, where fs is the Laplace transformation of ft. Okay, here our ft is sine 3t. Okay, this one is our ft. Therefore we will find what is the Laplace transformation of sine 3t. Okay, just use the formula where to find the Laplace transformation for sine. The formula is equal to a over s square plus a square. So your a here is 3. Therefore, you will have the fs equal to 3 over s square plus 3 square. So you will have 3 over s square plus 9. Okay, so this one is your fs. Step number 3, you will differentiate fs and time. Okay, you will differentiate fs and time. And for this equation, you have n is equal to 1. Therefore, you just need to differentiate your fs once. Okay, so you have your fs equal to 3 over s square plus 9. Okay, now you need to differentiate, or you need to find what is your f prime s. Okay, so how to find f prime s? If this one is a quotient, therefore you can use the quotient rule, where this one is u, this one is v. Okay, so list down here, your u is 3, your du is 0, your v is s squared plus 9, therefore your dv is equal to 2s. Okay, so the formula of quotient rule is v times du minus with u times dv over v square. So what you will have here is s square plus 9 times with 0 minus with 3 times with 2s over s square plus 9 to the power of 2. Therefore, what you will have here is 0 minus 6s over s square plus 9 to the power of 2. So your f prime s is negative 6s over s square plus 9 to the power of 2. Right, so here is your f prime s. Okay, so step number 4, you need to times negative 1 to the power of n with the answer that you have in the step number 3. Therefore, your n is equal to 1. Okay, you will times with negative 6s over s square plus 9 to the power of 2. Therefore, what you will have as your final solution is 6s. Negative 1 to the power of 1 is negative 1. So negative times with negative is positive. Therefore, you have 6s over s square plus 9 to the power of 2. So the second question, where we need to find the Laplace transformation for a function t square exponent 7t. So here you have the combination of t with the function exponent. Therefore, we will find the Laplace transformation of this combination of function by using t derivative of the transform. Okay, so the first step is to find what is the value of n. So from here we can see that our value of n is equal to 2. Okay, so we have n is equal to 2. Okay, for the second step, we need to find what is your fs, where fs is the Laplace transformation of your ft. So for this question, your ft is equal to exponent 70. Therefore, you will find the Laplace transformation, okay, of exponent 70. So if you can remember how to find the Laplace transformation of exponent is by using the formula 1 over s minus a, where here our a is 7. Okay, therefore you can find your fs. So your fs is equal to 1 over s minus 7. Okay, now in step number 3, we need to differentiate fs and times, where now our n is equal to 2. Therefore, we need to differentiate our fs here 2 times. Okay, so we have our fs equal to 1 over s minus 7. Okay, so if you want to differentiate, you can bring the denominator up into the numerator here. Okay, therefore what you will have here is fs equal to s minus 7
is negative
1,
which is approximately negative.
Okay, so differentiate f prime s is equal to negative 1 s minus 7 to the power of negative 2. okay, times with 1. Therefore you will have negative s minus 7 to the power of negative 2. Okay, we need to differentiate 2 times, therefore we do again the differentiation process here. So we have f prime prime s is equal to negative times with negative 2 s minus 7 to the power of negative 3 times with 1. Therefore what you will have here is 2 s minus 7 to the power of negative 3, or you can bring it down. So what you will have is 2 over s minus 7 to the power of 3 as your f double prime s. Okay, so you have done with the step number 3. Now we go to step number 4, where in step number 4 you need to times your negative 1 to the power of n. So now your n is equal to 2. Okay, with whatever that you get in step number 3, which is the f double prime s. Okay, therefore we will times negative 1 to the power of 2 with 2 over s minus 7 to the power of 3. Okay, negative 1 to the power of 2 is 1. Therefore, the final solution of your Laplace transformation for t to exponent 70 is equal to 2 over s minus 7 to the power of 3.